So what we're going to do is we're going to start with Introduction to Triangles, which is on lesson 1. This one here is introducing the triangle, naming parts of the triangle. So as we read on, we're going to talk about the different rules. So in lesson 1, Introduction to Triangles. So we know this already. A triangle is a three-sided figure. We know that way back years. Although it has 3 sides, it actually contains 6 parts because it has 3 sides and 3 angles. It has 3 sides and 3 angles. So if we are to solve the problem using triangles, we will need to understand a bit about the names of the parts of the triangle. So here, this is a triangle A, B, and C. Okay, the triangle above is called triangle ABC because it's from A to B to C. That's your triangle right there. The 3 angles are located at the vertices. So these are your angles. Angle A, angle A, so that's the opening, how wide the opening. Angle B, how wide the opening there, and then angle C, it's right there. And angles, the angles are at the vertices. Vertices are like the corner points. Okay, they're the corner points. And angles are uppercase. Okay, those are capital letters. Capital letters. A, B, and C. Now, each angle has a side that's opposite to it. A side that's opposite to it. So if this is your angle A, okay, your angle A is above. Right across from angle A is side A. This is side A. If this is your angle B, right across angle B is your side B. And if this is your angle C, right across is side C. Okay? And sides are the small letters. Small letters. Okay. So in this section, what we're going to do is we're going to try to find either the missing side. We're going to try to find the missing side, and it's indicated as X. If X, that's the one that we're trying to figure out. Or the size of the missing angle, and then it's denoted as theta. Theta. So that's this little symbol in here. Looks like an O with the line theta. So the first thing that we're going to learn about triangle is it's called Rule 180. Rule 180 or 180 rule. Okay. We're going to put this a star beside this because that's something that's very important. We're going to take a look at that later on. We said that the sum of the 3 angles in a triangle is always 180 degrees. The sum. Well, what does the word sum mean? The total, right? So when we total up the 3 angles, it's always going to be 180 degrees. Okay? That's what it means. So what we need to do is that if we know 2 angles in a triangle, we can easily find the 3rd angle by subtracting the 2 angles from it. So think about this one. Let's take a look at example 1. Example 1, it says here, we know that this is 47 degrees. This angle is 47 degrees. This angle is 62 degrees. We want to know how much this angle would be. So how can we figure that out? We know that if we add all of them up, it's 180. 180. Subtract, we're going to take away 47. We're going to take away 62. And that's going to give us our theta, the remaining. Whatever remains from the 180, that's basically what your theta is, your angle. So let's go ahead and calculate that one. You figured it out? 71 degrees. So theta is 71 degrees. So this is 71 degrees. Is that good? Yeah. Any questions there? Now this one here is a little bit different. Okay. So we know that this angle up here is 30 degrees. And then this one here we don't know, theta. This one is theta. But these two angles are equal to each other. So we know that it's going to be 180 subtract 30. So that's going to give you 150. But 150 should be split up between these two angles. Okay, yeah, so we have to divide that by 2. Divide by 2 to get 75 degrees. So that means this part, this angle is 75 degrees. This angle is also 75 degrees. Okay? So far so good? Now that we know the different parts of the triangle, so we got 3 angles denoted by an uppercase letter, a capital letter, and then we have opposite sides. The sides are lowercase letter. Now we're going to talk about the different names of a triangle. So different names. Equilateral. Equilateral triangle is a triangle where all 3 sides are equal length. The triangles shown are all examples of equilateral triangle. I'm actually going to break up the word equilateral. Like what, if you actually take a look at this, equi, that's like a short for equal. And the word lateral means side. So literally the word equilateral triangle means equal-sided triangle. Because this one means a short for equal. And then the word lateral. Lateral actually is used in biology pertaining to the side. So that means equal side triangle. Anybody taking biology? I did. You did? Did you talk about lateral side? Yeah, pertaining to the body, right? Oh no. But you've probably heard of lateral, right? So equilateral triangle. So you got 3 sides that are equal to each other. So 3, 3, 3, 14, 14, 14, 7, 7, 7. Now, the thing about this is sometimes instead of writing 3, 3, 3, 14, 14, 14, 7, 7, 7, sometimes there's like a mark showing that they're equal to each other. So sometimes hash marks are used to show that the sides of the triangle are equal length. This is in the diagram. So if there's a line there, that means that all 3 sides are equal to each other. Okay? So, since all sides are equal, that actually forces the angles to be also equal to each other. So rule 180, so if these are 3, 3, 3, then the angles are going to be forced to be all the same angles. So 60, 60, 60. And where did the 60 come from? We know that the sum of all the angles, if we total up all of the angles, it adds up to 180. But then it's split up to those 3 angles. That's where the 60 come from. Okay? So it doesn't matter how big your triangles are, the angles will always be 60 and 60 and 60. Okay? So let's take a look at example number 1. Well, the other example number 1. So 2 palm trees become unrooted from the sand on the beach and start to fall. They stop falling because their tops touch. Now that the trees make an equilateral triangle with each tree and the ground is forming the side of a triangle pictured. Now, how likely is this going to happen? But it says here, their equilateral triangle. State the size of the angle that each tree forms with the ground. Now, because this is an equilateral triangle, that means this side, and this side are all the same. So that means their angles are all the same. That's going to be 60 degrees. Okay. If there is a 30 centimeter between the base of each tree, how tall are the trees? Yes, yeah, that's right. Because they already said that the trees make equilateral triangles. So if this means this is 30 and their equilateral triangle, that means this is 30 as well, 30 as well for that. So 30, 30, 30. So there's 30 meters tall. That's a big tree. Okay. Is that okay? Ooh. This one is kind of fun because it says an old exam question, and I remember this question really, really well. I remember this. My students wrote this test back in the day. So it says here, a student is solving math questions involving a 100-meter truss bridge. The bridge is made up of 7 equilateral triangles. Do you see 7 equilateral triangles? Do you? Does everybody see 7? Can you describe the 7?
1, 2, 3, 4, 5, 6, 7.
Yeah.
Going up and down.
Yeah, so this is 1, yeah, 2, 3, 4. So you got 4 upright triangles, and then you have the 3 upside down triangles, right? There's 1, 2, 3. Okay, so everybody sees 7 equilateral triangles. So the bridge is made up of equilateral triangles shown. Have you seen a lot of the bridges in triangle shape? Have you seen a lot of triangular pieces around the bridge? Like if you think of like the bridges, like Redwood Bridge. I see a lot. Louis, is that what they call now? Yeah. Okay, they changed the name. Okay. So yeah, you see a whole bunch of triangles, right? And those triangles are there because triangles are actually pretty strong figure, right? That's why it's a whole bunch of triangle. If you look at your garage, the trusses of the house, there are a whole bunch of triangles because the triangles are actually a pretty strong shape. You can't really, it can take forces on each, and it's not gonna start to shift.
I think we call that Warren Truss. Warren Truss.
Yeah.
That's the name of the actor.
Yeah. Can I see? That's why it's called. Okay. Can I show it? Yeah. So this is like Warren Truss. Oh, I didn't know that, but this is usually the shape of the bridges, right? You have all these. Oh, I don't want to lose it. This is what the bridges look like. A whole bunch of triangles put together. Oh, I didn't know about it. It's named after somebody. Thank you. Good. So it's amazing the technology we have. We just Google it and it comes. So it says here, sketch one of the bridge's triangles and state all sides and angle measurements. So we know from here to here is 100. How big are the sides of the triangle? Divided by 4. So if this is 100, divide that by 4, because you have 1 here, 2, 3, 4. So that means this part is 25, 25, 25, 25. Yes? Is everybody okay with that one? 25. Now, because this is an equilateral triangle, so that means these are all 25s. I'm just gonna draw the lines there. Those are all 25. So the sides, sketch the bridge's triangle. So sketch one bridge. Okay, I guess I should follow the rule. Sketch one, so this is 25, and that makes this all 25 meters. And state all sides and angle measurements. So that means the angles are 60, 60, 60. Is that okay? Yeah. Just because it's an equilateral triangle, all sides are equal, all angles are equal for that one. Any questions there? So far so good? So we talked about a triangle that has 3 equal sides. Now there's another kind of triangle, a special name called isosceles. Isosceles triangle. What's so special about isosceles triangle is that it has 2 sides that are equal and the other one is a different length. So only 2 sides are equal. So here are some examples. 12 feet and 12 feet. These 2 are equal. This one is a different one. This is 4 centimeter, 4 centimeter. So these 2 are the same. The third one is not. And then these 2 are the same. This one is not. So this is called an isosceles triangle. What's interesting about isosceles triangle is that 2 sides are equal, and that also means that 2 angles are equal. So let's take a look. So this angle and this angle are equal to each other. So this angle and this angle are equal to each other. Okay, if I see, I'm going to try to show you something in here. If these 2 opens up to the same angle, this opens up to 12. And then this angle also open up to 12, so that means those two angles have to be the same. Okay. Let's take a look at this one. So which ones are equal to each other? Which angles are equal to each other? So this angle and this angle. Anything that's opposite to those equal sides. Now, which two angles here are equal? Yeah, the top corners. Excellent. Yeah. You see that? Yeah. So this part here, in the isosceles triangle shown below, find the angles labeled B and C. So these two sides are equal. That makes these two angles equal to each other. So how can you figure out angle B and angle C? Well, we're going to use the rule of 180 here. We know that 180 minus 110. Okay, 180 minus 110. So we're down to 70 degrees. And 70 degrees are split up between these two angles. So divide that by 2. That means this is 35. Angle B is 35 degrees. And angle C is 35 degrees. Okay, is that good? Just in the middle, blast it out. You want to stay? I'm just gonna finish it. Now, again, this is an old exam question, June 2017 to be exact. So it says here, state the type of triangle that is shaded in the. State the type of triangle. The type of triangle, I see that this is 36, this is 36, 120 degrees. This one here, we don't know. It's longer than 36. So this is called an isosceles triangle. Isosceles triangle, because two sides are equal. State the measure of angle C. Angle C. How do you figure out angle C? You know it's going to be 180 minus, if you take away the 120 rather, that's going to give you 60 degrees. Okay, but the 60 degrees have to be split up between angle B and angle C. So divide that by 2. Makes it 30 degrees. So the picture really looks like this. The top is 120. This is 30. And then this is also a 30. Okay. And that follows the rule of 180, right? Because 120 plus 30 plus 30, that's equal to 180. Okay, so far so good? Yeah. Quite a lot of stuff in here in lesson 1. Okay, so we talked about 3 sides that are equal. We figured out the name of the two-sided, the triangle that has 2 sides equal. Now what about the triangle that doesn't have any sides equal? That's called scalene. Scalene triangle is a triangle that has 3 different lengths. So if they have 3 different side lengths, that means they have 3 different angles. Okay, so that's what it says here. Since all 3 side lengths are different, then all angle lengths, then all of the angle, I think length is not the right word. All the angle measurements are also different. Because angle is not a length. Okay? And then we're going to use that later on. Yeah. So we can categorize a triangle based on the side lengths. Now, the other thing that we're gonna do is we're gonna categorize a triangle according to angle measurements. Okay? So, how do we categorize a triangle based on angle measurement? Who's heard of a right triangle before? Raise up your hand. Who's heard of a right triangle? Okay, so some people have heard of a right triangle, so let's take a look. What is a right triangle? A right triangle is a triangle that has exactly one 90-degree angle. The 90-degree angle is typically shown with the box at the corner. Note the right angle can be scalene or isosceles. However, the right triangle cannot be equilateral. Okay. So here, this is a right angle triangle. This angle right here is 90 degrees. 90 degrees where that little box in there. Okay, so this is 90 degrees. 90 has 190 degrees. The next one is called an acute triangle. What is an acute triangle? An acute triangle is a triangle that contains angles that are all less than 90 degrees. All angles are 90 degrees. Acute. Okay. And then last but not the least, obtuse. An obtuse triangle is a triangle that contains an angle, one angle larger than 90 degrees. So one angle has to be larger than 90 degrees. So here's an example of an obtuse, because one angle is greater than 90. So here we go. Let's take a look at example 1. We're going to classify on page 6. We're gonna classify the triangle as, is it a right triangle, is it an acute, or is it an obtuse? So you take a look at this one. Okay. This one is called the obtuse. Yeah, so this is gonna be obtuse. Obtuse triangle because it has one angle that's more than 90 degrees. What do you call this one? Right? Yeah, this is called a right triangle because the 90 degree at this corner here. And then what do you call this part? Acute. Acute because all of the angles are less than 90 degrees. Oh, they're giving us a lot of information in here, giving you a preview of what the provincial exam looks like, which is kind of nice. So it says here, Martha is building a triangular ramp over a drainage pipe. Okay. She's considering the following designs. Choose the letter that best completes the statement below. The type of triangle ramp that allows a wheelbarrow to be pushed smoothly over the pipe with the least amount of effort on either side. Which one do you think will have the least effort on either side of the pipe? So this one we know is a right. What would this be? If this is 80, this is gonna be So this is in the middle. It's going to be an acute isosceles, yeah, but it's going to be an acute because this is going to be 80. 100 subtract 80, that's going to give us 100. Sorry, 180 minus 80 is 100. And then that gives you 50 and 50 on each side. What about this one? This one is an obtuse triangle because you have an 180 degree, 120 degree rather. So which one would be the least effort if you were to push a wheelbarrow on each side? Acute, equilateral, obtuse, or right? Imagine yourself pushing something in here. Which one would have the least amount of effort?
The obtuse.
The obtuse? Yeah, obtuse, yeah. Yeah. Why is that? Why would that be? Because this is 120.
The angle is steep.
Yeah, this is going to be only 30-degree angle. This is 50-degree angle. So you're going to have less resistance from gravity. That's kind of... This is a loaded question because it becomes like a physics question.
It could also be the right possibly.
It has to be on both sides. It says here, equal the least amount on both sides. So if this one here is 20, then this would be 70. So that's not going to be it's not going to be a good, easy on both sides. Okay, so justify why this type of triangle should be used for the ramp, making reference to the base angles. The smaller angles would make it easy to push up. What are we pushing up again? Wheelbarrow. This becomes like a science question all of a sudden. Page 6. Okay. How do you like that one? So there's quite a bit of stuff, right? Quite a bit of stuff. We talked about naming the sides, naming the angle. We talked about Rule 180 rule. We talked about naming naming the kind of triangle based on the side lengths, and then we also talked about naming the triangle based on the angle measurements. Okay. So there's, as usual, we have an assignment 1. So this one is, don't take it for granted. Make sure you work out each question. Some questions in here on assignment 1. And then tomorrow we will have to set this aside, right? Because we have our test tomorrow. Okay, so I'll leave that with you.